Hello my students, now welcome in today's presentation. We're going to look different things, but the first one is all about progressive waves. You'll be asked to define or to briefly explain what do you understand by progressive waves. But I want to remind you what we discussed on the past few weeks that concern about the types of waves. We said we have two types of wave, which are mechanical waves and electromagnetic waves. Remember, this part is still on the way to come, but we have done with mechanical waves. We said mechanical wave is the wave which needs material medium for it to propagate. But today and here, mechanical waves is of two kinds, which are transverse waves and longitudinal waves. Today, we are coming with another description or another concept of wave, which is called progressive waves. Therefore, you can be wondering, why this, and where does this come from? But don't worry. Progressive waves is just a special case on mechanical waves. Remember, progressive wave is a special case of mechanical waves. Therefore, a progressive wave can be either transverse wave or longitudinal waves. Now, what this special case? What this special case? A progressive wave is from the word progress. You know, progress means continue. To progress means to continue. Therefore, a kind of mechanical waves which continue is called progressive waves. Oh no, that is not a physics word. Continue how? A kind of mechanical waves where which travels onwards without change of amplitude. The big concept there, progress now here is coming from is explained by the word does not change amplitude. Amplitude does not change. Therefore, the special case here, we consider amplitude to remain constant. But when we talk about other kinds of, we talk about mechanical waves, we do not consider either amplitude is remaining constant or not. But for progressive, that means from equilibrium point to next point, amplitude, if it is 2 meters, it will remain to be 2 meters. This is what we call progressive wave. We can have a simple illustration here. The kind of wave which travel onwards without change amplitude. Look here. This amplitude remain the same. This amplitude remain the same throughout the process. This kind of wave, we call it progressive wave. Now, sometimes progressive waves is also called traveling wave. Traveling wave. Therefore, if you'll be asked to define what is a traveling wave or progressive wave, is the same things. Is the mechanical wave whose amplitude does not change as it moves onwards from one point to another. Now, if here amplitude is 2 meters, will mean to be 2 meters, 2 meters. That means it's the kind of mechanical waves which does not die. It continues to travel, to travel, to travel, to travel. It happens always. This is what we call the progressive waves, or sometimes we call it the what? Traveling wave. Now, traveling wave is of two kinds. I said progressive is mechanical. Mechanical is of two kinds. Therefore, if a transverse wave travel from one point to another without the change of amplitude, we call it that transverse wave to be transverse progressive wave. If a longitudinal wave travel from one point to another without change of amplitude. We call the longitudinal waves to be a longitudinal progressive waves. Therefore, progressive waves are of two types. The first one is called transverse progressive wave, and also have longitudinal progressive waves. Their definitions, they are very simple. A mechanic wave whose amplitude does not, is the transverse wave whose amplitude does not change. Is the longitudinal wave whose amplitude does not change as it moves from one point to another. Therefore, that is just progressive waves, and what we want to know is those ones. Therefore, as it moves from one point to another, amplitude does not change, but also it carries energy from one point to another. After progressive wave, we're going to another concept. This concept is called superposition principle. We're going to look the principle called superposition principle. You'll be asked to state the superposition principle. What superposition principle explain? Superposition principle explain the following. When two or more waves travel in the same region at the same time, the resultant displacement wave is given by the vector sum of the individual displacement. That means if you have two waves, maybe you have this one, and we have another waves, which is this one. Now this has displacement y1, this is displacement y2. The resultant, that means the combination displacement between these two waves, is given by the vector sum. The resultant displacement is given by the so-called vector sum of the individual displacement. If you want to know what will happen if these two waves will combine, you must take the vector sum. That means you take the vector sum of y1 and y2. That is what superposition principle. Why did we say the vector sum? Here what is vector? Has magnitude and direction. Therefore, during superposition, we consider the directions of these two waves. The resultant displacement is obtained by looking the directions. If they're in opposite direction, that means one will be negative, the other will be positive. But if they are all in the same directions, both of them will be what? Positive. You add accordingly. That's why we are saying vector sum. That means in superposition principle, we consider match the direction. Is it positive or negative? Are we going to add or are we going to subtract? That is it. I think you remember the concept of relative velocities. We consider the plus or minus because velocity is what? Because velocity is a vector, and here displacement is a what? Is a vector. Therefore, generally, the resultant displacement of a wave according to superposition principle is given by y equals to y1 plus y2. They depend on how many waves do you have. y3 plus dash dash until to yn. But remember, we consider match directions. If they move in opposite directions, that means y will be equals to y1 minus y2. If they're in the same directions, y will be nothing but y1 plus y2. This is what we call the what? Superposition principle. We consider match the vector sum. That means the directions. Now, due to superposition principle, we have different phenomena which obtains after superposition principle. And for today is what we are going to look. We have different phenomena. We have different features which arise after this principle of vector sum. The first principle, that means superposition principle, give us the rise of the so-called stationary waves. Therefore, through superposition principle, we have the so-called what? Stationary wave. Therefore, stationary waves are the wave obtained from what? Superposition principle. But also, according to the superposition principle, we have the so-called beats. We want to know what is beats, and here we are going to, on the few days to come, we're going to explain about beats. But also, superposition principle is the one which gives us the so-called resonance. Superposition principle is the one which leads us to have the so-called what? Interference. Therefore, superposition principle leads us to have these phenomena, and we want to explain about these phenomena. And the end of these phenomena will mark us at least to say now wave is nearby to be end. But for today, we are going to start with stationary wave. Now have a short break. We're going to begin with stationary wave.